All right, so it is day 2 of the ambiguous case, and hopefully you guys did the only homework that I told you to do, which was learn all of these rules. And if you did that, then today's lesson is going to go by a lot faster. So just as a reminder, this is called the ambiguous case for sine law. And the idea is sometimes you're going to get information that leads you to the sine law because there is an opposite angle and side length. However, based on the information given, there are actually going to be 2 ways that you can draw the triangles, and that's why it's ambiguous. It's uncertain. So to solve this type of question, you actually have to show both of the triangles and do all the calculations for both of them. So really quickly, because I know we spent a lot of time on this, our triangles will always be SSA, side length, angle. We will always draw them in this position. We will first look at the angle and determine if it's obtuse or acute. Obtuse is greater than 90 degrees. And for the obtuse triangle, it's actually pretty easy because you don't have to do any calculations. You just compare the A length and the B length. So if the A side length is smaller than B, or if it's the same length as B, no triangle exists. But if A is longer than B, then only one triangle exists. So you can never have an ambiguous case when it's obtuse, but you can have a no triangle or a one triangle. If you have an acute triangle, then what you're going to do first is always calculate the height using just SOHCAHTOA. And then you're going to compare the height and side length A. Now, what you need to remember is once you've calculated the height, you're really looking at it in a right angle type of way. And you're going to remember that this is the hypotenuse, which always has to be the longest side. So when you compare the H and the A, if A is shorter than H, or if it's the same length as H, then no triangle, or sorry, if A is smaller than H, no triangle exists. If A and H are the same, a right angle triangle exists. And if A is greater than H, then that could potentially be the ambiguous case. We need to do our final check. To do our final check, we are going to be checking A and B. Visually, if you draw it correctly, if your triangle leans to the left, that is not going to be an ambiguous case. And the reason is you can only draw it in that one way. You can't take that A length and swing it around. So that's the only type of triangle you can have. If A and B are the same length, again, only one triangle exists. But if A is shorter than B, then that is an ambiguous case because given the information, you can draw the triangle in the original form, or you can draw the triangle by swinging the A to the other side and drawing it like this. In the case of an ambiguous case, you're going to have about 6 calculations that you need to do, and you're going to have to draw 2 different types of triangles. And this type of question would be worth about 7 or 8 marks. So you definitely get rewarded for all the work that you do, and it is a longer question. So in yesterday's class, any questions about that? We know all of our rules. In yesterday's class, we had done, one second. All right, so in yesterday's class, we did question number 1, and then we did question number 2. And I know there are a lot of questions, but honestly, there are going to be many situations where you end up with no given triangle and you don't have to do a lot of work. So yes, for ambiguous case, you got to do a lot of work, but in the other situation, you don't have to do anything. We're going to go ahead and start question number C. So question number C has a little bit of a mistake. If you could just change this to little b instead of capital B, that would be great. And for this question, we're first going to figure out where all the angles and the side lengths go. So I draw my rough triangle. I'm just going to assume the triangle's like this. I'm going to be putting 30 degrees here. I'm going to be putting 25 centimeters here. And then I'm going to put 30 centimeters here. So when I draw this properly, I know my 30 centimeters has to be a lot longer than my 25 centimeters. And the reason why I'm really specific in doing this, because if you get the lean part right, then it kind of gives you a hint visually if it's going to be ambiguous case or not. So when we draw it properly, it's going to be base, and then this is going to be the longer side length, and then this is going to be the shorter side length. And I can see this triangle leans to the right. So I'm going to call this angle B, which is 30 degrees. And this is side length B, which is 25 centimeters. I'm going to call this angle C, and this is side length C, which is 30 centimeters. And then the other angle is A, and this is going to be side length A. Yeah, just to see what way the triangle is leaning. All right. This is definitely an SSA triangle and it is acute. So when something is acute, we're going to start off by first finding our height. And we did this about twice last class, so I feel we're pretty good at it. Also, if you're like me and haven't taken out your calculator, take out your calculator and make sure it's in degree mode. By the way, on Monday, make sure you bring your own calculators because the ones I have are really, really bad. You don't want to be using them and no one's going to be allowed to use phones, okay? So just make sure you have your own calculator. Okay, so I am going to go ahead and do sine 30, a little too loud, you guys, is equal to h over 30. And so h is going to be sine 30 times 30, which is going to give us 15 centimeters. Okay, so let's compare our H and our, in this case, it's the letter B, but really it's in that A position. If that B is greater than H, is that allowed? Or be allowed to have our hypotenuse bigger than the letter H? Yes. So B is greater than H, and we're going to write our little proof. So B is greater than H. So therefore, we're going to go ahead and check for the ambiguous case. Now we're going to compare the B and the C, which are like technically our A and B in the original diagram. And we're hoping that the B is smaller than C, because if that's the case, first of all, your triangle is going to be leaning to the right. And then also that B is short enough that it can swing over and give you another triangle. So in this case, we do notice that our B is smaller than C. And so therefore, two triangles exist. We compare this side length and this side length, and we always want this one to be smaller and this one to be larger if it is ambiguous case. And the reason why is if it's small, then it can swing over to this side and it can give you another type of triangle. All right, so we're gonna buckle up because this is gonna be a lot of different calculations. First, we're gonna actually go ahead and calculate for the original diagram that we drew. So what are the missing parts? There are always gonna be three parts or three components of the triangle that are missing. I always begin with calculating angle C. We're gonna go ahead and use sine law and calculate for angle C. So it's gonna be sine C. And if you didn't want to write the formula, that's fine. You can go ahead and plug in values as you go. So sine C is going to be over side length C, which is 30. And the only two pieces of information we know are sine B and side length B. So it's going to be sine 30 over 25. Okay, so we're going to end up getting sine C is equal to, we multiply sine 30 times 30, because remember, cross multiplication means you move that 30 in the denominator to the top and multiply them together, and then you divide by 25. So in your calculator, you're going to go sine 30 times 30 divided by 25. And if you wanted, you actually don't have to write this part down. You could actually, on your calculator, go ahead and just put in sine inverse. So I think, Denoya, this is a good way for me to show you when we're going to be using sine inverse. Here we have sine angle C, and I end up getting 0.6. So whenever you're trying to find an angle like angle C, here is where you're going to use the sine inverse button to give you what that angle is going to be. We'll go ahead and round everything to one decimal place. So this is going to be 36.9 degrees. To find angle A, now it's pretty straightforward. We're going to use our interior angle theorem. So all interior angles add up to 180. So it's going to be 180 minus 30 minus 36.9. So angle A is going to be 113.1 degrees. By the way, the reason this is called ambiguous case for sine law is, first of all, the triangle sine law, and also you never need to use cosine law to solve anything. Okay, it's just always going to be sine law. Finally, to find side length A, we can't use Pythagorean theorem because it's not a right angle triangle, so we have to use sine law again. And to do that, we're going to go side length A over sine of A, which is, we just calculated that, 113.1 is equal to, and now we actually have enough information to use either B or C. It's your choice. I personally always pick the numbers that were given to me in the original question. So I pick like this stuff because I know for sure those are the right numbers. So it's going to be 25 over sine 30. And again, we're just going to use cross multiplication. So we're going to go sine 113.1 times 25 divided by sine 30. Do we need to use sine inverse or anything like that in this question? No, you're just trying to find the side length. It's 45.99. So it's going to give me 46, not degrees, centimeters. Okay, so we found 3 of the missing things in the first triangle. By the way, you don't have to actually label the triangle with this stuff. It gets too messy. So as long as you have it written like this, it's fine. Okay, now here is the new part. Here's the part we haven't done before. Yeah. No, you don't. You definitely don't have to. Yeah, just squared, highlight, underline. Yeah. Okay, so now we're ready to draw our next triangle. And for this triangle, we are going to start with our base. And we're still going to have this side length. This is not right. Let me do that one more time. So it's going to be a small section here, and then it's going to be like this, and then it's going to be like this. And basically, this triangle is pretending that side length B over here has now shifted over there, and this is our new triangle. Okay, that's basically how we're drawing it. We're shifting side length B over and drawing it there. Now, remember, I told you guys yesterday that when we're labeling this, we have to use the letter prime to show that it's a new angle, a new component. So angle B doesn't change because it's going to remain 30 degrees. That is the same. Angle A, we're going to have to calculate again. And so because we're calculating that again, we're going to call it angle A prime. Side length C doesn't change. It is still 30 centimeters. And technically, side length B is the same measurement, but because it's changed its position, I am going to call it B prime, and I'm just going to say 25 centimeters. And then this is angle C prime, and this is side length A prime. So you can see in this diagram, we're going to have to find angle A prime, angle C prime, and then side length A prime. Now, because that side length B is swinging over here and making an isosceles triangle, this and this are actually the same angle. So you know how we calculated angle C was 36.9? The angle over here is also 36.9. So to figure out this little dot over here, what we're going to do is we're going to go 180 degrees minus 36.9. So that's why it's important to know it's an isosceles triangle. You don't ever draw the isosceles triangle, but it's very important to know how to figure out that new angle C prime. All right, so to show our work there, we are just going to go ahead and write down actually going to use completely different colors. So angle C prime is going to be 180 degrees minus whatever C was, which is 36.9. So it's going to be 180 minus 36.9, and it's going to be 143.1 degrees. And then from there, if we know what angle C prime is, can we figure out angle A prime? Yes, we can, because it's just going to be angle A prime is just going to be, again, interior angles. By the way, angle C prime follows the supplementary angle rule, like all the angles in a straight line add up to 180. And then angle A prime follows the interior triangle rules, where all the angles in a triangle add up to 180. So 180 minus 30 degrees minus 143.1. And we expect this to be pretty small. 6.9 degrees. So don't be alarmed if you find that this angle is very small. That's expected, because look how small angle A actually is. We can't round this, so it's just going to be 6.9 degrees. And then finally, we're ready to find side length A prime. And for that, we're going to have to just use our sine law again. So let's go ahead and do that. So it's going to be side length A over sine of 6.9 is equal to, and I'm just going to use my B's. So it's going to be side length B, which is 25, over sine of angle B, which is 30 degrees. So we're just going to go sine 6.9 times 25 divided by sine 30, and I get 6.006. So rounded to one decimal place is just 6.0. Okay, question D. Hopefully you guys are getting a little bit better at drawing the diagram. So go ahead, make a rough sketch of your diagram, and then see if you can figure out the official diagram as well. My letter P became a diamond. Okay. So little p is equal to 24 centimeters. Q and little q, 48 centimeters. This is R, and this is little r. Okay, so here's my PQR triangle. I've drawn it such that it's leaning to the right, and that's because side length P is much smaller than side length Q. I just do a quick check. I know this is a side-side angle triangle, and also the angle is acute. So my first step is going to be to go ahead and calculate H. Okay, so to calculate H, we're just going to go sine of 30 is going to be equal to H over 48. And so H is going to be sine 30 times 48, which is going to give me 24 centimeters. So I'm just going to write that here. Okay, so now that we figured out H, we're going to compare H and side length P, right? Because it's in the A position. What do you guys notice about H and P? They're both the same. So look at your chart, and what happens when both of them are the same? What kind of triangle do we have? One right angle triangle. So let's first write down that information. So we say P and P is equal to H. Therefore, one right angle triangle exists. So messy. I'm trying to erase and it's not erasing. Okay, so how are you going to draw the right angle triangle? Well, it's just going to look like this because P and H are the same. So we're going to have angle P over here, and that's 30 degrees. Angle Q is now 90 degrees. Angle R is up here. This is Q is equal to 48 centimeters. This is P is equal to 24 centimeters. And you're literally just going to use SOHCAHTOA to solve the rest of it. So I'm going to start by solving angle R, because it's going to be 180 minus 90 minus 30, which is just going to give me 60 degrees, right? It did not connect. And then to figure, so that was this right here. And then what am I missing? I think the only thing we're missing is side length R. So you can literally use anything you want, sine, cos, or tan. I'm going to go ahead and use tan 30. So I'm going to say tan 30 is equal to opposite, which is 24, over adjacent, which is R. You can only actually use cosine or tangent. Oh, yeah, with the angle 60, you're right. Tan 30. And so I end up getting 41.6 centimeters. I need to fix that or else it's going to bother me. All right, we have, for question E, we have our very first obtuse angle. So when we draw this, we have to sort of draw the angle to be very large. And I don't know what the rest of it looks like. So I'm just going to assume for now it looks like this. And then, ooh, that's really big. Let's make it a little smaller. Our obtuse triangles always have an angle that is greater than 90 degrees, so it's going to look kind of a little bit weird. This is angle X, so this is 120 degrees. This is side length X, so this is 40 centimeters. And I still put the other side length, which is Z, and this is 20 centimeters. The other X, so this is going to be Y. Sorry, I made a, no, I have not made a mistake. This is going to be Z, this is going to be Y, and this is going to be side length Y. Okay, you guys, let's do this question together, and then I'll let you do the last couple by yourselves. So when we do our check for this, it is still a side-side angle triangle, but this time it's obtuse. So an obtuse triangle makes life a little bit easier because you don't have to actually solve much. You just need to compare this and this. So your A and B position. And you need to make sure that this side length is the largest because it is opposite from the largest angle. If that side length is not the largest, then no triangle exists. Luckily, in this case, 40 centimeters is larger than 20 centimeters. And so one triangle will exist. And we need to write that as our proof. So we're going to say side length X is greater than side length Z. Therefore, one triangle exists. Go ahead and solve the triangle. It's just using sine law and what we've been doing. So I'll do the solutions. You can check your work after you're done. Do we need to calculate H in this question? No. So here's another example where we're going to have to use the sine inverse button. It's going to be sine 120 times 20 divided by 40. You don't need to write this step, 0.4330. And then you use sine inverse to figure out the angle, and you're going to get, I'm getting 25.7 degrees. Okay, then in order for us to figure out the next side length, which is y, we're just going to use the interior triangle rule. So 180 minus 120 minus 25.7. So angle y is 180 minus 180 minus 120 minus 25.7. So I'm getting 34.3 degrees for that. And then finally, to figure out side length y, we're going to do sine law again. So y over sine y, which is 34.3, is equal to and it doesn't matter what you use. I'm going to go ahead and use 40 of the x's. So 40 over sine 120. So the calculation for this is going to be sine 34.3 times 40 divided by sine 120. And it's 26.09. So it's going to be 26.1 centimeters. Why is it not changing into a square? Okay, I'm going to struggle off recording for this. All right. For question F, I'm going to draw the triangle because I know you guys are already working on it. So this is going to be angle E, which is 140. So I'm going to move this over a little bit. There we go. So angle E, which is 144 degrees. This is side length E, which is 10.5 centimeters. And then this is angle F. And then this is side length F, which is 12.5 centimeters. And then this is angle D, and this is little d. All right, for question F, we have a side-side angle triangle, and we notice it's obtuse. So we are just going to be comparing E and F. Is it possible or allowed for side length E to be 10.5 centimeters, which is less than 12.5? No, it's not, because remember, angle 144 is the largest angle, which means side length E must be the largest side length. So no calculations required for this, which is wonderful. We are just going to write our little proof. We are going to say side length E is less than side length F, therefore no triangle exists. No. Oh, and that's actually a really good question. So if I were to give you, let's say, 3 or 4 ambiguous case questions, I wouldn't write how much they're out of on the side because that'll give it away. So I just give you the total marks that it's out of, because a question like this would be probably out of 1 mark, whereas the other question would be out of 8. So if I told you it was out of 8, that would be a big giveaway that it is ambiguous case, so I wouldn't tell you that. But this question would be literally 1 mark, half for the diagram, half for the proof. Okay, question G, the last one. So hopefully you guys have already started drawing it out. That's little, so it's going to look like this. If you draw your triangles correctly and your triangle is leaning to the right, you should be really careful because leaning to the right triangles could possibly be ambiguous case. So that's sort of our first hint to what's happening. Okay, this is angle M. this is side length M. I do want you guys to try this question yourselves, so I will give you time to do it. This is acute. So when I've drawn my triangle, I do recognize that it is acute. So I'm going to start off by calculating for H. All right, let's do our comparison. So our height is 11.6 and M is 12.6, which is great because we want M, which is the hypotenuse, to be greater than the height. So we check for ambiguous case. Then we compare L and M, and we notice that M is smaller than L, which means that letter M can swing around and make two different triangles. So this is an ambiguous case question, and you're going to do it on your own and then check your work as you go along, because we've already done one together. So try this one on your own. Okay, so I talk to myself while I do this. I'm going to say, yeah, the two side lengths. So in this case, we compared H and M. L, yes. It's, yes, yes. So in this case, M is greater than H, so therefore we check for ambiguous case. And then we notice that M is less than L, therefore two triangles exist. For the first triangle, you don't have to draw it again because we've already drawn it. You just have to draw the second triangle again. Or you draw the second triangle for the first time. Okay. So I'm going to begin with angle L. Say sine L over 15.6 is going to be equal to sine 48 over 12.6. I'm using M over here, like sine M over little m. And then to solve for this, I'm going to go sine 48 times 15.6 divided by 12.6, and then sine inverse here because we're trying to find the angle. So it's going to be 66.9 degrees. Okay, then we can go ahead and find angle K, which is 180 minus 48 minus 66.9. So angle K is 180 minus 48 minus 66.9. So it's going to be 65.1 degrees. And then we're ready to find side length K. So side length K over sine 65.1 is equal to 12.6. You guys are probably going to be so sick of sine law after this that you'll probably forget how to do cosine law. 12.6 times sine 65.1 divided by sine 48 is going to give me 15.4 centimeters. Okay, I'll just pause here so you guys can check your first 3 measurements with mine. Let me know if it's correct or if I did something wrong. Okay, then to draw the next one, it's going to be a little line and then kind of have to slant this one. No, I didn't do it right. Let me do it again. So like this, and then like this, and then like this. Oh, I didn't change it to a triangle. Ariane, you can try to actually do it so that you're not bored.
Oh.
M prime is equal to 12.6 centimeters. So that was a delayed reaction to what you said because I was just in the middle of drawing this and figuring out what it was. This is K prime, this is L prime, and this is little k prime. Okay, so now we're ready to solve this. We're gonna go. The hardest part about the second case, you guys, is just remembering that in this case, angle L prime is 180, it's an isosceles triangle. So it's 180 degrees minus whatever the original L was. So 66.9. And I get 113.1 degrees. Okay, then so where you go here. Now I'm gonna do angle K prime, which is gonna be 180. It's so funny, Kavya, because we're on the exact same step, I think. Oh, we're not? Yeah. Yeah. We'll keep it to 1 decimal place at least. You are rounding as you go, so your answers are getting less and less precise, but don't round it to a whole number, 1 decimal place. And because I'm doing that in my answer key as well, I will get the same answer as you. And then finally, we're ready for K prime, which is going to be over sine 18.9, and we can use our m's. So it's going to be 12.6 over sine 48. So our final answer is going to be K prime is equal to sine 18.9 times 12.6 divided by sine 48. Which gives me 5. Oh, what do I get? 5.5. Okay, I'm gonna show you the whole solution so you guys can see if you got the right thing. I was just saying, and once you're done this solution, there are textbook questions. It seems like there is an error in the solutions in the back, and then there's handout C, which is this ambiguous case handout. I would say this is probably really good. And do you have to do every question? No, because that's a lot. In fact, I wouldn't even worry about questions 4, 5, 6, 7, 8. I would just worry about that first handout, 1 to 3, and maybe pick and choose a couple. Yeah, we haven't done any of those. Those are more like application questions. Okay, so I'm just gonna show, I'll come back to this. I'll show you guys what handout I'm talking about. It's this one right here. So if you want to just take a screenshot, and you can pick and choose which ones you want. You definitely don't have to do every question on here. It's a lot.